Okay, hello and welcome to week 14. Whoops. All right. Thank you for joining me. So, a couple of announcements. Wednesday and Thursday, I will not be in the office. I have a 2-day meeting, so I will not be in the office. Okay. And then Friday morning, I will be here 8 to noon, and then CTech will most likely be closing at noon. They don't tell us in advance, they just surprise us. Hey, surprise, we're closing, you guys can go home, which makes it awkward if we need to tell students that we won't be here. Okay. If you still need to take the exam, it will be full credit the week after Thanksgiving, and it won't be a 0 when I calculate your grade for the quarter grade that is coming out.
Oh, wait, the exam grade, did it already go in?
It went in this morning.
Oh yeah, because my grade dropped.
It shouldn't have dropped much.
No, it was a bit.
Yeah.
But I thought it was an assignment.
Right. So that was the exam. If it drops a full letter grade, if your week 13 exam makes it drop a full letter grade, then I will remove it when I put the progress report in. But if it's not a letter grade, I'm not going to worry about it. All right, let's get started. Okay. Now, for week 14, we are looking to solve an equation. This is a power function. Notice my base is the variable, but my exponent is a number. So I can do raising something to the 4th power. So what is the opposite of the 4th power? There's 2 ways to say opposite of 4th power. One of them would be the 4th root, which is difficult to do on the calculator, but the 4th root is the opposite of the 4th power. The 4th root would cancel the 4th power, and we would be left with x. But another way to write that is the 1/4 power. Okay, so what do I do with these 2 exponents if I have base to the power to the power? So I have this and this, and what do I do with those 2 exponents? They cancel. If you're trying to read my mind, the word I'm looking for is multiply them, right? So we multiply these together and they cancel. Whenever you have base with 2 exponents, you multiply. So those cancel and you would be left with x. So 4th root is the same as 1/4 power. They are both opposite of x to the 4th. So let's do, since it's easier on the calculator, let's raise both of these to the 1/4 power. So if everyone would grab a calculator out of the box that says Lysol. I need 125 to the 1/4 power. And we are going to round to the 100th place. So we do 125 exponent parentheses 1/4. If you forget the parentheses, you're not going to get the right answer. You should get rounded to the hundredths 3.34. Okay, so remember to have those parentheses. Okay, B. Now there's a long way and there's an easy way. Okay, so here's what this is saying. X to the 0.5 is equal to 8. 0.5 is equal to what fraction? Thank you, 1/2. Now, I'm going to do something to both sides. To cancel a 2 on the bottom, I need a 2 on top. Yeah, 2/1. Everyone see how that's going to make the exponent on my variable disappear? Okay. So now cancel and X comes out and I get 8 squared is 64. So there's one way to look at it. Now, what if we just want, so this is how it makes sense. Hopefully this one makes sense. There's a quicker way to look at it. Okay. So now if I just want to do this quickly, I can raise everything to the 1/0.5. Now you might not like this. It's just kind of a shortcut. So can everybody see that 0.5 on top cancels 0.5 on the bottom? So we get, okay, so I need you to take 8 to the parentheses 1 divided by 0.5. And if you do the calculator correctly, you should get 64. Because 1 divided by 0.5 is 1 divided by 1/2. Dividing fractions easy as pie, flip the second and multiply. So X is 64. So whatever that decimal is, you can just raise it to the 1/whatever that decimal is, and you can get the correct answer. When it's 1/2, this method probably makes more sense. But if it's some crazy decimal, we're going to use that shortcut. Okay. Number 2. Now, the 5th root. 2 ways to look at this. I can look at it as 5th root or 1/5 power. So 5th root is the same as the 1/5 power. So how do I solve for X? What is the opposite of either 5th root or 1/5 power? What am I going to do to both sides? So we're going to raise it to the power of 5. Okay, 5th power cancels 5th root. With your calculator, 6 to the 5th power is 7,776. Okay, let's do this one. Let's write this as a fraction. Okay. The power is 3. That goes on top. Yeah. The root is 4. That goes on the bottom. Okay. We're going to raise everything. Now, how am I going to cancel a 3 on the top and a 4 on the bottom? Okay, the reciprocal. So I'm going to raise it to the power of 4 on top. 3 on the bottom. Okay, cancel. So I need 64 to the 4/3 with parentheses. 64 to the 4 divided by 3 is 256. Okay, these two are on your own. Or stick around and we'll talk about them at the end. Now let's do this one. Step 1 is isolate. So I need to peel off the easiest number. So which number is the easiest to peel off? Okay, so I'm going to divide both sides by -2. Thank you, Zoomers. So I'm going to have n plus 13 to the -1/2 is equal to +1/2 Okay, so we're going to leave it as a fraction, not a decimal. But you could replace it with 0.5 because it's a nice clean decimal. But we're going to leave it as 1/2. Okay, now I'm going to raise both sides to the what power? How about -2? Yeah. So -2/1. Okay, cancel the negative, cancel the 2, and n plus 13 comes out. So what is 1/2 to the -2 going to be? What is the negative exponent going to do? Ooh, okay. Good question. Is an exponent of 2 going to cancel a denominator of 2? No. Okay, do you see the difference between this and this? Okay, so glad this came up. Do we see the difference? These you're multiplying. These we are not. So this would just be X. This would be, let's plug it into the calculator and see what we get. 1/2 to the -2 power. I'm guessing it's a 4. Where did the 4 come from? We squared the 2, but we also, what does a negative exponent do to a fraction? Ellipse it, cross the line, change the sign. Okay, so this is the same as 2/1 to the +2 power because the negative exponent flipped it, which is 4. Okay, so this is 4. That's a 1. It looks like a 7. And then subtract 13. So n is equal to -9. Okay, and this is why we've been practicing a lot of exponents. It shows up every week in your attendance quizzes because we've got to be really confident with these exponents. Let's do another one. So we're going to isolate. And we're going to undo the exponent. Now, is there anything I can do to isolate? Is there anything not included in the parentheses that I can divide by? Okay, there's nothing to isolate. Number 5, we could divide by that -2 because it was outside the parentheses. Okay, so we're going to raise both sides to what exponent? Okay. 2/3 cancel. So we have 2a plus 16. With your calculator, 512 to the 2/3. Equals 64. Basically, I took the cube root and I got 8 and I squared it and I got 64. Okay, and we're going to finish. Subtract 16. 2a is equal to, what is that? 48. Divide by 2. A is equal to 24. Okay, we're going to cross this one off. We're not going to do that one. If you want to see one more example, that is on last year's video. Okay. These are on your own. Okay, change my mind. These are do not do. Okay, that is review of last unit. You definitely need to know how to do these, but we're not going to practice them again. Okay, number 10. This is not a power equation. This is an exponential. Okay, so step 1, isolate. Step 2, if okay, so we talked about this last week. How do we solve an exponential? If the, anyone remember? All right. If the bases are the same, then the exponents are the same. Okay, so we have 5 and we have 625. We need to look at the table of powers. What do you notice about the table of powers that's going to help us with this equation? Ah, 4. Okay. Someone says 4, our other cadence. 4. What about the number 4? Okay. So in the 5 row, 625 is 5 to the 4th. Yeah. So we're going to go back. Okay. So I have 5 to the 1st. And I replace 625 with 5 to the 5 to the 4th. Okay, if the bases are the same, then the exponents are the same. So I take the exponents and bring them down. Now you're doing a ed puzzle this week, and she says you cancel the 5s. You're not really canceling the 5s, but we're bringing down the exponents. So 2 minus 2a is equal to the 4. Not canceling, but if the bases are the same, then the exponents are the same. So now we're going to solve. Draw a line down the equal sign, subtract 2. And divide by -2. Okay. Number 11. Now, personally, I don't like fractions. If I move the 64 to the top, what is that going to do to the exponent? It's going to make it negative. Yeah, do we see that? So we're going to say 64 to the negative k. A negative exponent flips the fraction. So if I want to move it, I have to change the sign. Is equal to 2 to the -1. Right? If I want to flip the fraction, I have to introduce a negative exponent. Okay, now what do? I go to the, okay, so I'm going to go to the table of powers. And what do we notice? I'm guessing it's in what row? Oh, it is in the 4. But do I want it to be 4? Look at our problem. I really think it's going to be in the 2. Yeah. So can we add to our table? What if it's not in the table? What is 2 to the 6th power? Ah, there it is. Yeah. And I could see because it goes 4, 8, 16, 32, multiply it again. The next one would be 128. Okay, 2 to the 6th power is 64. So this is 2 to the 6th. And this is 2 to the -1. Okay, if the bases are the same, then the exponents are the same. The base is going to disappear. We're going to bring down an equation with the exponents. So Zoomers, can you type in what my equation is that I'm going to bring down? What do you think? Okay, 6 times -k is equal to -1. So -6k is equal to -1. Last step. divide by -6. And we're not going to change that to a decimal because it's not a nice clean decimal that I know of. What is 1/6? 1 divided by 6? No. It's a repeating decimal. We're leaving it as a fraction. Okay, number 12. A little different. Now we have a root. We have a radical. Step 1, isolate. Step 2, I'm going to introduce a word, inverse. Inverse is the opposite. The opposite of multiply would be divide. The opposite of square root would be square. So we're going to say isolate, inverse. Okay, so let's isolate. What do I do to both sides? Divide by -8. Okay, so I have +7 is equal to square root of x over 10. Now, does everyone see that you cannot multiply both sides by 10? Why can I not multiply both sides by 10? It is part of the square root with the x. Yeah? So it's very important that you see that that 10 is inside the house. You cannot multiply both sides by 10. Okay, next step, inverse. The inverse of square root is squared. Okay, so I know that squared cancels square root. So I have 49 is equal to x over 10. The 10 was in the house with the x. The 10 is now free. So what is my last step? Multiply by 10. X is equal to 490. Okay. Next. So we're going to go isolate, inverse, and solve. Okay. Step 1, isolate, add 2 to both sides. Be very careful with that B, that it doesn't just become another 6. Next step. Let's keep isolating. I have not completely isolated my variable. No, think simple. How can I get rid of that 36? So we're going to divide by 36. Yeah, see how we're going to completely isolate. Now I have my variable and I have my exponent. Now 64 over 36. Everyone have one of my calculators? So you're going to go 64 ABC 36. Uh-oh, I got a mixed number. So I'm going to go second ABC equals second ABC equals. All right. So this reduces to divide by 4, 16/9. Okay, you should be able to reduce fractions on the calculator. Okay, what's the last step? Square root both sides. Square root of 16 over square root of 9. Now, if there's an exponent of 2, we have two answers, plus or minus. So B is 4/3 and -4/3. Whenever you have an exponent of 2, you're going to have two answers. Okay. Now, we kind of talked about this. This 6 has a power and a root. Okay. The roots are under the ground. The power is up above the ground. So the 2 is the power and the 3 is the root. So we have radical form and what do we call this? Exponential equation. What is it? Anyway, we're changing it to radical form. Exponential form. So we're going from exponential form to radical form. Okay, so now step 1, deal with the negative. So I'm going to flip the fraction. Because we don't want to leave things with negative exponents. Okay, so now the root is 2, the power is 3. The root is 2, the power is 3. Well, it didn't really help, but okay. So this is 3b, and we're going to write this in exponential form. What is the exponent on that 3b? What's the top number and what's the bottom number? Zoomers, what's the exponent on that 3b? Seven is the power, 4 is the root. Radical form to exponential form. Okay, this one's on your own. Okay. We're going to skip these. If you have not taken your exam yet, then you need to review these, but we're not going to do these right now. We've done plenty. If you want to see them, they're on last year's video, and they were on the week 13 exam. Okay, let's talk about number 20. Notice if it said this, then we multiply. The donut is G of H, which is G of H. So this is, the donut is composition. So that means plug H into G. Okay. So step one, we're going to rewrite G of H of 3. Anyone have a guess? It's okay if you don't have a guess. Anyone have a guess of where I would start? Guessing actually helps you remember it longer. Ooh, careful. Not G of 3. Nope. H of 3. Yeah, can you see that our first step is find H of 3? So step 1 is take 3 and plug it into H. So H of 3 is 3 squared minus 5 times 3, which is 9 minus 15, which is -6. Okay, what's my next step? So H of 3 equals -6. So now I'm going to do G of not 3. What? No, -6. Yeah. So I take the answer and plug it in right there. Okay, so I'm going to take G of -6. So 4 times -6 minus 3 is -24. Minus 3 is, what's -24 minus 3? -27. So G of H of 3 is -27. So I do H of 3, I get an answer, I plug that into G. So the math is not that bad. The notation is new and confusing. Yes, the donut means of. Okay, so now notice, why are you doing that? Okay, now there's no number there. Donut, G of H of X. G of H of X. Is, instead of H of X, what could I put in the parentheses? I'm going to take out H of X and replace it with X minus 3. Which means, so G of X minus 3 means I'm going to take G and I'm going to plug in X minus 3. Yeah. So see how X minus 3 went in right there. That's a plus. Now there's nothing to distribute this time. So this is just X minus 3 plus 2, which is X minus 1. So G of H of X is X minus 1. So this is not quite a great illustration, but let's say I was doing an experiment and I had a plant. If I give it vitamins, then it grows. If I get it vitamins and I put it in the sun, then it grows more. What if I give it vitamins and put it in the sun together? See how I'm doing two things to my variable. So that's kind of what this is doing. Okay. Okay, this is the worst. Whenever the outside number has an exponent, that one's the worst. Okay, I'm just going to tell you this is as bad as it gets. So let's take G of f of x. So I'm going to take G of 2x plus 2. And I hate it when the first one has an exponent. Even I don't like them. So I'm going to take 2x plus 2 and plug it in both places. So whenever I do these, I look at them and I'm like, if the F was the first one, yay, that was not bad. If the one with the exponent is the first one, it's bad. Okay, so now I have to make a box. 2x plus 2 squared is 2x plus 2 times itself. Okay, so let's make a box. 2x plus 2. We have 4x squared. 4x and 4. So this is combine like terms. 4x squared minus 8x. Sorry, plus 8x plus 4 minus 2x plus 2. So 4x squared plus 8x plus 4. I need to distribute the negative. Minus 2x minus 2. Four x squared plus 6x plus 2. Okay, these are not bad unless you actually have to make a FOIL box in the middle of the problem. And then my attention span just goes, lose interest. So I'll admit, that's not fun. I hate having to make a FOIL box in the middle of a composition problem. but the rest are not bad. It makes you appreciate the other ones. Okay, let's do this one. Oh no, look how complicated it is. Is this a bad problem or a good problem? No, this is a good one. Why is this good? Because the easy one is the first letter. Do you see how this is so much better than number 22? You want the easiest one to be the first letter. This is not bad. Okay, f of g of x. Which is f of negative 2x squared minus 3x. Now, I don't mind distributing and combining like terms. I hate it when I have to make a FOIL box in the middle of a composition problem. Okay, so let's do this. Equals 4 times my x minus 3. Okay, so this is negative 8x squared. Oops. Negative 8x squared minus 12x minus 3. Done. Yeah. So see how 22 is much harder than 23 because you want the simpler expression to be the first letter. And then it's not that bad. We're just distributing and combining like terms. Okay. Last one. Let's talk about exponential equations. First, let's ignore that side. Okay, so what do we notice? Okay, so we're going to call this r equals 4. Does everyone see that we're multiplying by 4? And where does it begin? Okay, it begins at 0, 3. Okay, so everyone sees it begins at 0, 3 and multiplies by 4. What if I go backwards? What's happening? If going to the right is multiplying by 4, going to the left is dividing by 4. Yeah? Okay, so I can write this as 3 times 4 to the first power. Can I write this as 3 times 4 to the 0th power? What is this? What is anything to the 0th power? This is 1. This is just 3 times 1. So are we good? 3 times 4 to the 0th, 3 times 4 to the first. Okay, let me get rid of this. Okay. Is this 3 times 4 again? Do we agree? Because I took 3 times 4 and I multiplied by 4. Let's try it. 3 times 4 times 4. 3 times 4 times 4. 48. Does everyone see where I got that? So this is 3 times 4 squared. So this is 3 times 4 times 4. I need to multiply by another 4. Yeah, see where I got that? that makes this 3 times 4 cubed. So now, without even doing this part, I can tell this is going to be 3 times 4 to the 4th. Now, you need to look. Some numbers are not changing and some numbers are changing. The variable, is the variable going to go into a number that's changing or not changing? So A is where it begins. B is the multiplier. So A is it begins at 3 and we're multiplying by 4. Therefore, the equation is, take a look at this. Where am I going to put my variable in? 3 times 4 to the x. Okay. We're done. Okay, so we have a request for number 3.
So we were getting look at the participants, if there's anything you need to ask me. And if there's any notes, examples, or formulas you want to write on your paper and use on the test. And we'll just be a couple more minutes.
Okay. We have a request for number 3. We are going to, I think, is that what you meant by typing that 3 in? We're going to isolate. And we're going to do the inverse. And we're going to solve. Okay, isolate. Can I add, subtract, multiply, or divide anything? Or are all those numbers stuck in the house? They're stuck. Do we see that the 1 and the 40 are stuck in the house? So no isolate. I'm going to do the inverse. So what am I going to do to both sides? I'm going to square both sides. Okay, squared is the inverse of square root. So 1 minus 40v comes out. And we get 81. Square root has 1 answer. Squared and absolute value have 2 answers. Okay, subtract 1. Negative 40v is equal to 80. Divide by negative 40. V is equal to negative 2. Sorry, square root has 1 answer. Okay, number 4, isolate. Inverse. and solve. Okay, is there anything that is not locked in the house that I can get rid of? Okay, divide by 9. Okay, isolate. Next step is inverse. What do I do to both sides? Square both sides. 1 squared is 1. Square root cancels squared. And then we're going to add 1 to both sides. P is equal to 2. And I like to lead with my variable. Seven. Okay, we are going to do number 7. Okay, let's do it. It'll be good. Isolate. Inverse. And solve. Step 1. What would be the, yes, add how much? Okay, because it's the easiest to get rid of. Everything else is trapped inside the parentheses. Okay, next step. Not multiply. What do I call it? Raise everything to the 2/3 power. Yeah, we're going to be super careful with our vocabulary. Two on top, 2 on the bottom, 3 on top, 3 on the bottom. So I get -9 minus 3k, 729 to the parentheses 2/3 is 81. Okay, great. Great. So you're going to come over here. I think that will be good. I think that'll help. Okay, next step. Add 9. -3k is equal to 90. Bye-bye, thanks. Divide by -3. K is equal to -30. Okay. I kind of went a little faster because I wanted to get everything done. Yeah. Yeah. Okay, are we good? All right. Okay, thank you. Okay, you're welcome. Thanks for coming.